This is the first day for 12.2. So it's day 1, graphing rational functions. We've been calling them inverse, right, relationships or inverse functions, but these are really, their formal name is rational functions. And what defines them is they have this x in the denominator. The parent function is this that I just wrote. This is the parent function. In other words, the function that the simplest version of a rational function, and all of the other rational functions are going to be derived from it. And in other words, rather than starting the way the book does, which is just going one by one, I'm going to show you our final point, just because I think at this point you guys are pretty savvy and you know what a and h and k do to functions, because we're using the same values each time. So you've already seen we've had y equals a over x, and so a is the first change. And if you remember what a does and always does, a makes this a stretch or a shrink, right? So if a is greater than 1, it's a stretch. If a is between 0 and 1, in other words, it's a fraction or it's a decimal, it's a shrink. And if a is negative, in other words, if a is less than 0, it's a reflection. And that has been the same whether we've done the quadratic, whether we've done an exponential function, right? Every single, and the square root function, a has always had the same function. The next part we're going to look at, now I'm just going to make this fraction bar just a little bit longer, because on the bottom I'm going to put a minus h, which you probably remember was inside the square root, right, in chapter 11 when we did the square root function. And this one had the same role that it had in square root and quadratic, etc. And this accomplishes horizontal translation. In other words, it moves this whole function, this whole hyperbola, because this is really hyperbola, side to side. And then if I add a k, this is what's going to give my vertical translation. In other words, it's going to move it up and down. If you know these things, it's going to make it a whole lot easier to graph. And that's one of the reasons I started this whole chapter on graphing with just that, okay? So having done that, I'm just going to define the parent function, which I mentioned up here. The parent function for all rational functions is y equals 1 over x. And it has its very own characteristic. When I draw my coordinate system, let me just move this up so you can see the whole thing. And I'm going to draw my hyperbola in blue. Here's the branch, right? If you remember from the last lesson, we have 2 branches, and in between we have the asymptotes. So the very basic function for the hyperbola is called the parent function, and it has particular characteristics. So, sorry, that's the buzzer for my dryer. So the first thing is the domain and the range. Can be any value except one value. You can see that these branches get close. It can be any value, but the one value they can't be is 0 for either the x or y. So are all non-zero real numbers. Okay, that's a fancy way for saying they can be any number except 0. The second thing that is clear about this parent function is the asymptotes. And I alluded to this a little bit in the last lesson, are the x-axis and the y-axis. Asymptotes being the lines that they get very close to but never exactly hit, okay? I realize you can barely see this, but hopefully you can hear me and see. These branches get very close to that y-axis and very close to the x-axis, and therefore the x and the y-axis are actually the asymptotes of the parent function. Okay, our next step is to go forward and then just draw a bunch of different functions. And the whole purpose of this chapter, at least the beginning of the chapter, is to say, okay, let's do an a that is bigger than 1, and let's see what a stretch looks like compared to the parent function. Let's see what happens when we do a shrink. Let's see what happens when we do a reflection, or when we add an h value or a k value. And so that's really what the bulk of this chapter is going to be. So let's start. And we're going to start with, and for each of these we're going to have to draw the parent function. So the first one is comparing compare y equals a over x to the parent function y equals 1 over x, okay? And to do that, we're going to try to first draw, and we're going to do 2 versions of this. One that's going to be a stretch and one that's going to be a shrink. So the first one is going to be, and I guess maybe I'll do the stretch in purple. Y equals -2, let's see, over x. And you'll notice they're not only stretching it, in other words, they're not only making a greater than 1, but they're also adding a negative number in front, which is going to make it a reflection. So if I redraw my parent function, and I've been drawing it in blue, so I'll just stay consistent. Here's my parent function. And if you remember the parent function, this was, I didn't draw it particularly well here, but this is 1, 1, 2, 1/2, etc., etc. 1/2, 2, right? So this is 1, 2, and it's around the same thing here. This is too far from the axis. Unfortunately, I didn't draw it as well as I should have, but you get the idea. So I'm gonna this is my parent function, y equals 1 over x. And I'm going to do in purple y equals -2 over x. Well, to do that, I'm just going to throw some xy values over here. Obviously, x can't equal 0, so we're going to ignore that. I'm going to put in 1 if x is 1, y is -2. You can see right down here. If x is 2, y is -1. X is, let's see, let me do 4, y is -1/2. So essentially you can see this is going to be y equals -2 over x, and same thing over here, y equals -2 over x. And again, I didn't do a great job of drawing it, but if I had drawn this before sorry for the noise, before I flipped it, you would see that this would have moved up and been a stretch before the reflection. Same here, this would have been a stretch before the reflection. Let me move over here, and I'm going to redraw my parent function and hopefully do a much better job of it. Oops, in blue though. So y equals 1 over x. Yeah, that looks a little bit more like what it's supposed to look like. And I'm going to draw y equals 1 over 3x. In other words, it's the a here is really 1/3. And if I do my xy values over here, I can see that if x is 1, x still can't be 0 because 3 times 0 is 0, right? So that can't work. But fx is 1, y is 1/3. So it goes from here down to here. If x is 2, y is 1/6. So again, further down here. And you can see that literally what is going to happen is you're going to have a function that is going to be a shrink, that's going to be closer to the x and y axes than the parent function. And I should have labeled those actually properly. Okay, so this one you can see is a shrink. It comes closer, right? It's closer to the xy axis, to the asymptotes. And this one here is a reflection, because it's negative, right? A is less than 0. And it is also a stretch, because A is 2, not 1, right? So it is a stretch because the absolute value of A is greater than 1, okay? And I should have stated this is a shrink because A equals 1/3, right? And so it is A is greater than 0 but less than 1, okay, the absolute value of A. Okay, so that takes care of what does A do. And actually, that's what I think I'm going to title this. This is what does A do, okay? A will do a reflection, and A will do a stretch if it's greater than 1, or a shrink if it's less than 1. We're going to turn next to look at what H does. I showed you what what K does, not. I showed you that equation. So I'm going to just flip back for a second because we asked what A does, right? And if you looked here, this is what we looked. We looked at what does A do, and now we're going to go back and say, okay, what does K do? Okay, and we hypothesized that this is probably a vertical translation, but we're going to watch that work out. So I'm going to stop the video before we do that, and I'm going to start again in a minute.